Welcome to a short video showing how to calculate European call and put valuations using the BlackScholesMerton option valuation model. Now, from your reading, you should know that financial options give the owner the right but not the obligation to buy, call, and to sell put at a fixed price at a predetermined future date. Now, European options, unlike American options, can only be exercised at maturity date. Now, these names do not indicate location. They are traded worldwide. It is an interesting model that was created from the heat equation using partial derivatives. Now don't worry, no calculus here. However, the original model was based upon cylindrical round objects of uniform composition, so use it with caution. Now many traders today use the put-call parity instead of this model. The put-call parity for a non-dividend paying stock is the call price equal to the put plus the stock price minus the present value of the strike price. Now with dividends, I would also subtract the present value of the dividends. I will give you these equations in the weekly overview. Now here is the Black-Scholes-Merton equation. It is the call price is equal to the stock price times a normal distribution of D1 minus the strike price times Euler's number raised to the negative R or percent times a time frame times the normal distribution or D2. Now here's the equation for D1 and D2. You can see variance and sigma and natural log, which again is Euler's spelled Euler's number spelled E-U-L-E-R apostrophe S. It's pronounced Euler's though, which is the number 2.71828, etc. This should sound familiar. It's used for continuously compounding rates. And here's the two D1 and D2 if you'd like to create your own model in Black-Scholes. Just remember that these cells are my cells, so if you have, like, the stock price is not B3, it's B4, make sure you change it within your model. Now let's go ahead and see some of the factors that affect options. Now, first of all, the strike price and the stock price. As widening occurs, I'll go ahead and increase the stock price to $45. You can see that's good for the call and not for the put. Basically, as widening occurs between the two, it's good for the call since there's a better chance the investor will be in the money. Exercise date. Now remember, American options can be exercised before expiration. Therefore, the longer the time, the more valuable the option is. So here's term. I'll go ahead and change it to 0.75 or 3/4 of a year instead of a half a year. And again, both went up. Volatility. I'm sorry, risk-free rate. The higher the risk-free rate, the more valuable the call option, but the lower the put option. And finally, volatility. The value of an option increases with volatility. So I'll just go ahead and change it to 30% here, and you can see the change. Let's go back to risk-free rate, and I'm going to go ahead and change it to 9%. And let's take a look at the call. The call does go up. Let's go back to, let's just change it to 10%. And once again, the call option does go up as well. Finally, down here at the bottom, I have both the call and the put formulas here. Now the put was a little more difficult. It required a little bit of a change. First of all, the strike price had to go first here, and D1 and D2 are negative here.